The joint hypothesis test for multiple exclusion restrictions is called the F-test. The F-test concerns two models: the restricted model and the unrestricted model. The restricted model is the model in which the restriction is imposed. The unrestricted model is the model without the restriction. The restriction is that the three coefficients of the performance variables are 0 in our case. So the restricted model must be shorter than the unrestricted model. The F-test compares the sum of squared residuals from the restricted model to that from the unrestricted model and determines whether the change is large enough to reject the null hypothesis. The sum of squared residuals is a measure of the variation of the outcome variable that cannot be explained by the explanatory variables in the model. Since the restricted model has fewer explanatory variables than the unrestricted model, the sum of squared residuals in the restricted model must be greater than the sum of squared residuals in the unrestricted model. In our example, the sum of squared residuals from the restricted model is 198, and that from the unrestricted model is 183. The variation of players' salaries that can be explained by the model decreases when the three performance variables are excluded from the model. In other words, the unexplained part of the variation increases as those three variables are excluded from the model. Whether these three variables are statistically significant depends on the relative change. That is, the change in the sum of square residuals relative to that from the unrestricted model. The F statistic is defined as follows. The numerator is the change in the sum of squared residuals, and the denominator is the sum of squared residuals from the unrestricted model. Both are adjusted by their degrees of freedom.